this video we're going to talk about composite functions, which can be a little bit confusing upon your first encounter, but once you get the hang of it, they're actually pretty straightforward, particularly if you approach them in a nice systematic, methodical kind of way. So I'll give you some tools to make sure that you develop those habits early on and don't ever get too confused with composite functions. So with composite functions, it's a really good idea to bear in mind your machine analogy, which we talked about when we had a single function, which basically says that you get some numbers or some apples, and you put them through the function machine, and it does something to them, and something comes out the other side. Okay, so if you remember our terminology, we have domain is what goes in, and the range is what comes out. And there are restrictions on that depending on what your function is. So the machine analogy works really nicely for composite functions because you're just doing it twice. So you're putting some numbers in, you're putting them through one function machine and you get an output, and then you put them through another function machine and you get a different output. So here we've got G and F, and this is sometimes be a little bit confusing to start with. We say this is f of G, okay, and I'll explain why it's that way, but we're doing G then F in a minute. Alright, so if we have a look at some numbers, we've got these two functions here. Function f is x squared, and function g is x plus 1. So if we put x equals 3 into function f, so it goes in here, it gets squared, out comes 9. Okay, so that's your output, that's your range. Your input is your domain. Now before we do anything else, we're going to take that 9, which is the output of function f, and we're going to input it into function g. So this now will be 9, 9 plus 1 gives you 10. Okay, so we've put it through one function machine, we've gone x equals 3, 3 squared is 9, we've got that output, then we've taken that output, put it into g, 9 plus 1 gives you 10. Okay, and we call this one g of f of x. So the reason it's written this way, even though we do function f first, is because of the way BIMDAS works, okay, or nested brackets. So what we're actually doing is you've got to do the internal brackets first and work your way out. So we look at x, we apply f of x first, and once we've got that, then we apply g of x. So think of doing the inside brackets first, or if you're writing it in this notation, you do the second one first. So f and then g. So the thing you really need to remember here is what's happening with the range and the domain, because the function itself is fairly straightforward, and I can show you how you can find the composite function, but you can come a little bit unstuck because there might not always be a composite function. So we really need to bear in mind what is the domain and range. So what we've got, if we're starting with f, okay, so this will be function g of f of x, because we're doing f first. Okay, so we're starting with this. This is your domain of f. So these are the numbers that are going in here. Domain goes in. Okay, and then the range comes out, or the numbers that come out. Range of f comes out. Then we're going to take those numbers and we're going to put them in here, and that becomes the domain of g, and the numbers that come out at the end is the range of g. Okay, so what you might be able to see now, or at least start seeing, is that sometimes you might get numbers that come out of here that can't go into here. Now in this case it's not too much of a problem because here we've got a linear function and this can take all the real numbers. But if you had something that has a restricted domain, and if you've got numbers coming out of here that won't go into here, you're going to have an issue. So what we say is that for a composite function to exist, the range of f, so this, the output, range of f, that must be a subset of the domain of g. So this is the domain of g, so that's this one. So basically what that's saying is these numbers that come out of f must all be able to go into g, otherwise you won't get a composite function. Now the way we write this with our set notation is range of f is a subset, so that means is a subset of. So range of f is a subset of the domain of g. Okay, and if you bear that in mind, if you just keep thinking what comes out of here must be able to go in here, you can't go too far wrong. Okay, so in reverse we can do the same thing. Instead of having gof, g of f of x, we can have f of g of x, or fog. So if you start hearing us talking about fogs and goffs, this is what we're talking about. Same idea, it's just now that the range of g becomes the domain of f. So you've got numbers coming in here, this is your range of g coming out, and you take those numbers and they go in there, and that's the domain of f. So you can probably see that maybe if you've got a couple of functions where it works this way, so the range of G works and fits within the domain of F, it might not work the other way. So you can't assume that just because fog exists, then goff exists, because it might not. Okay, so beware. In general, G of f of x does not equal f of g of x. There would be cases where it would be the same, but that's not the normal case. So don't go assuming that those are the same. Okay, so let's get stuck into a couple of examples because that'll really help show you what I mean. So find the compositions of these two functions. So when it says compositions, that means find fog and goff, assuming they exist. Okay, so the first thing you need to do is check if they exist, and the way we do that is by checking the domain and range. So particularly when you're doing this to start with, it's a good idea to write down, before you do anything else, write down f, domain and range, and g, domain and range, and then you can check straight away. Okay, so if we look at, let's do f of g of x first, f of g of x, so that means we're doing g, then goes into f, which means we want the range of g has to be a subset of the domain of f. So let's have a look at that. Range of g is R, domain of f is also R. Yep, it's all good. So that one exists. Okay, now going the other way, g of f of x. So that means we do the function f first and then g. So that means the range of f, what's coming out of f, must go into the domain of g. So what's coming out of f, x is greater than or equal to 1. Okay, is that a subset of all the real numbers? Yes, it is. So that exists as well. Okay, so now we've got both fog and goff, and we can actually work out what they're going to be. Alright, so let's start with our fog. Now the easiest way to do this is just use your substitution of functions. So basically it's like a nested function. So you put your g of x in here, and then you expand using f of x. So instead of writing g of x, I'm going to write this part, so x minus 5. So we have f of x minus 5, because this x minus 5 is g of x. Okay, so that's equivalent. And then when I'm doing this, I'm just going to say, well, anywhere I see an x in f of x, I'm going to replace it with x minus 5. So I've got 2, and then I've got an x, so that's x minus 5, squared, that's where that comes from, plus 1. Okay, and you can leave it like that. If you need to expand it in order to solve it or something, or you want to expand it because it looks nicer, it's up to you, but it's perfectly acceptable to leave it like that. Same thing in reverse for goff, g of f of x. Okay, so g of, now f of x is this, 2x squared plus 1. Okay, now I'm going to go back up to g of x, and anywhere I see an x, I'm going to replace it with this whole thing, 2x squared plus 1. Okay, so we've got x, 2x squared plus 1, minus 5, and this one I will simplify because it's really easy. So 2x squared minus 4. And that's your compositions. So we've got f of g of x and g of f of x. You can do this on your class pad using your define function. So, oops, bring that over here. Clear this first, okay. Alright, so using, we've got 2x squared plus 1, and then do a define through there. F is fine. Okay, and then we had x minus 5, and we want to define that as g, so when we go up and do define, just change that to g. Okay, and then class pad will quite happily let us go f of g, oops, not those ones, f of g of x, will give us this, which is what we had over here, and we can do it the other way around as well, g of f of x, and that's what we had on the other side. So, good old class pad. But of course this often turns up in your calc free section of your exam, so you need to know how to do it. Just use your good old noggin as well. Okay, let's have a look at this one. So we've got two functions here. F of x equals x squared minus 4, and g of x equals the square root of x. Okay. Do the composite functions exist? So we need to check fog and goff. Okay, so we can see how this works. So if we start with fog, so fog means we're doing g into f. So do function g, what comes out of g goes into function f. So that means we're looking at the range of g, which is this one. Does that go into the, sorry, this one. Does that go into the domain of f? Yes, it does. So that exists. Okay, and then looking at gof, so function f first, then g. So on the range of f, which is x greater than or equal to minus 4, and the range of g. And now we have a problem, because we've got x is greater than or equal to minus 4, which means also minus 3, minus 2, minus 1, but the domain of g says that you can only have x is greater than or equal to 0. So if we don't restrict the function f, then this isn't going to work. So no, that doesn't work, because there'll be values such as minus 3, minus 2, minus 1, which you can't put in here, obviously, because you can't have negative values in here. Okay, so yes, that works. No, that one doesn't. Alright, so let's find what fog is, because that's pretty straightforward. So f of g of x, doing our substitution again, f of, that's g of x. Okay, so now we've got square root of x squared minus 4. Okay, now you might be really tempted to go, well, that's easy, because x squared minus, sorry, the square root of x squared is just x minus 4. But what you need to be careful of is that you still cannot put negative numbers in here, okay, because you're doing g first. Function g will not take negative numbers, so you can't have negative numbers going in there. So even though that looks like it should have a domain of all the real numbers, it doesn't. So if you do that, you have to say such that x is greater than or equal to 0. So it's only defined when x is greater than or equal to 0. Okay, so we can restrict the other function to make its range a subset. Okay, so in this case we want to restrict f such that the values that come out will be able to go into g. Okay, so basically what we need is we want the values f of x must be greater than or equal to 0, because we can't have anything that's going to be less than 0, anything that's going to be negative in here. So we need to do the restriction this way. So restrict such that f of x is greater than or equal to 0, and now we're just putting this in, x squared minus 4 greater than or equal to 0. Okay, now if we're solving this, it's easy just to do with a quick sketch. Okay, the graph of x squared is a parabola around the origin. Whoops, it's a bit lopsided. 4 is up here somewhere. Okay, we want the value such that x squared is greater than 4. So we are looking at this bit here and this bit here. Okay, so you should be able to see, well, if that's x squared, then this is going to be minus 2. This is going to be, oops, I'm saying 2 and I'm writing 4. There we go. This is y equals 4 up here. Alright, so the values that we want are x will be less than or equal to minus 2, or x is greater than or equal to 2. And that makes sense, because if you put minus 2 or minus 3 or minus 4 in here, you're going to end up with a number bigger than 4, because the squared gets rid of the negative. Okay, and then same for this one. So if you write the function of f, so this one, such that x is less than or equal to negative 2, or greater than or equal to 2, then your gof will exist. Okay, so you have to put those conditions on there. I'm just going to pause this and we'll pick up the third example in the next video.